Everyone, I'm Won Lee. I have been explaining about the sample a little theoretically, right? So today's topic is distribution of X bar. What is X bar? X bar is what? Sample mean. Okay, see a little more detail today. Okay, here, distribution of X bar. Actually, it is sampling distribution of a sample means, but it is too long to, say. So shortly, you can understand distribution of X bar. When a sample is represented by random variables, told you yesterday, say x1, x2, xn, random variables, capital letters, okay? Then the sample mean is denoted by capital letter X bar. Okay. Then capital letter means what? Random variable. Okay. Random variable has some distribution, probability distribution, and it will have a mean and a variance. Anyway, okay. X bar is capital X1 plus X2 plus Xn divided by n. You know, the sample mean like this. All right, since these are capital letter random variables, so X bar is capital letter random variables. X bar is also a random variable. Therefore, X bar follows some probability distribution and has a mean and a variance. Okay, I mentioned population. Population can be denoted by random variable x. There are many values in the population, so has some probability distribution function, f of x. Also, x has a mean, we say mu, and variance, say sigma square. Okay. Now we have random variable x bar. X bar has some distribution with mean and variance. Understand it? The mean of X bar is the population mean, mu. Mean of X bar is something like this. That's why I explained expectation a little. Okay, so you can get this one, and this is 1 over n expectation of x1 plus dot dot xn. Then expectation x1 is what? Expectation of x1 is what? Mu. You can ignore subscript. Expectation xn, what? It's also mu. How many mu's here? N mu's. That's why it is mu. I hope you understand this step. Okay, that's a lot better to you. And the variance of x bar is sigma square. Sigma square is what? Population variance over n. Okay. So the probability distribution of x bar follows some distribution we don't know yet with mean mu and variance sigma square over n. N is of course the sample size. It is a little theoretic explanation. Okay, for reference, sample mean x bar of measured values, real values, small x1, small x2, small xn, then we get x bar from these values. We can calculate actually x bar. It's just a sample computed value. Or sample is just a sample mean computed from data, right? Okay, let me explain a little more about this. To clearly understand the distribution of x bar, let's consider the following simple example. Suppose there is a population. Population consists of 15 integers, 0, 1, 2, 3, up to 14. Okay? 15 integers. And we like to get a sample of size 6. Then how many samples are possible to obtain. That is 15 combination 6. We take 6 of them this way, or this way, this way, that way, okay? There are many, about the 15 combination 6 is 5,005 different samples, okay? Of course, in theory, in your mind. Then, this different sample means each of them has mean, sample mean, right? See, for example, if you obtain sample 2, 4, 6, 8, 10, 12, sample mean will be 7, the mean of these 6 numbers. Or if you get sample 1, 3, 4, 7, 8, 13, then sample mean is calculated as 6 from these values. And another one, sample is 0, 7, 8, 9, 10, 14, then sample mean is 8, and so on, etc. How many this sample means? 5,005. Many sample means. Okay? Then, some of the sample means may be the same value, while others may differ, right? Okay, X bar. The value X bar get here, from here to here. Which one is smallest sample mean? The smallest value of 2.5 sample value, okay, sample mean is 2.5, which when it is come out 0, 1, 2, 3, 4, 5, 6. When you take 6 numbers like this, sample mean 2.5, largest value 11.5. When the sample values are 9, 10, 11, 12, 13, 14, then the mean of those values is 11.5. So smallest 2.5, largest 11.5, the X bar will be obtained from 2.5 to 11.5. There are many of them here, around here. I mean, many of them means the same value. Okay, 1. Here, 1. This sample means 5,500 sample means distributed as like this, between 2.5, 11.5. Okay? So X bar, capital X bar, will have some distribution between these two values. In practice, we just get one sample. In practice, we obtain only one sample, X1, X2, Xn, out of 5,500, 5,005 possible samples. Okay? So we get actually just one sample mean. It is X bar. So that's why we have to distinguish small letter and from capital letter. Capital letter is random variable. Small letter, what? Is realized sample value. You understand this example? This is simple, but if you don't understand this kind of a thing, you may have hard time to understand statistics. Okay? I think all of you understand this part easily. Thank you. Bye.